17.6 is over selective precipitation. In selective precipitation, we can use a value for Q, which is based on your initial values of equilibrium, just like it was with our other equilibrium problems, to figure out if something's going to precipitate out or if it's going to dissolve. So say we have a solid dissociating out into ions. When the solid dissociates out into ions, if we have an initial value for our ions, we can use that to find Q. And if Q is a lot larger than the value for KSP, that means you have a lot more ions than you're supposed to. Our equilibrium is going to shift over to the left, and that means we're forming a lot more solid. That means we're going to have precipitation occurring. If Q is equal to KSP, the equilibrium already exists, so you have a saturated solution. It's not going one way or the other. If Q is less than KSP, that means that you have not formed very many ions yet, and so it is going to dissolve until Q is equal to KSP, and then it will reach equilibrium and your solution will be saturated. Okay, and let's take a look at an example problem dealing with this. Here you have a solution that already has some silver ions and some lead ions in it, and we're going to toss some chloride ions into it. And we're going to try to figure out how much chloride do we have to add to make silver chloride precipitate out and lead chloride precipitate out, and which one goes first. So we treat this as two separate problems, one with the silver chloride and one with the lead chloride. And I'm going to go ahead and start with the silver chloride first. And this is actually pretty similar to the one that we did together in class. Our solution has an initial value of 0.01 molar silver already in the solution and no chloride in the solution. I'm going to toss some chloride in, and I'm going to see, all right, how much chloride do I have to add before this thing starts precipitating out? And I can use my KSP value to figure this out. So I set this up in an equilibrium expression, and now I can solve for x. So now that I know this, I can go ahead and I can figure out how much chloride I need to add to get the lead chloride to precipitate out. So here's my equilibrium equation. My original value of lead in the solution, no chlorine in there yet. I'm going to dump some chlorine in there. And I'm going to solve for how much chloride I had to add. And if I go ahead and solve for x, I get 1.46 times 10 to the negative second. But notice I want to know how much chloride I added, and I added, the amount of chloride I added was 2x, so I need to take this number and multiply it times 2. And if I do that, I get 2.9 times 10 to the negative second molarity. And so, since the PbCl2 requires a larger concentration of chlorine than the silver chloride does, then your silver chloride is going to precipitate first. And then the last section of chapter 17 is qualitative analysis. And quite honestly, there aren't any set things I'm going to tell you about this. Mostly this is just using general knowledge from things that we have learned in labs. Specifically, our qualitative analysis lab is going to be our big help. The things that are most important for you to know to be able to handle qualitative analysis. You want to make sure that you know colors. So things like copper tends to be blue-green, nickel tends to be green, permanganates and potassiums tend to be purple, things like that. Irons tend to be red or orange or yellow. You know, you want to know those things. You also really, really, really want to know solubility. And then the third major thing you want to know are reactions. Because in qualitative analysis, there'll be questions like, you have this compound, you add an acid to it, it forms a gas, you toss it in water, it dissolves. Which of these is it probably going to be? And if you know the solubility rules, if you know basic reactions, and you know colors of substances, then you're going to get most qualitative analysis problems right. We're going to work through several qualitative analysis problems together in class so we can practice these. There's also some at the end of your chapter 17 homework problems. This last section kind of goes through and shows you an example of some qualitative analysis that uses common types of solubility separations and precipitation reactions, where you have a solution, you add some hydrochloric acid to it, and you cause some precipitates to form, and you heat it up, and you can separate out these precipitates by heating it and then adding some other things to it. And this is a real common type of selective precipitation lab. But again, those three things, color, solubility, reactions, that's going to get you through most of it. So I wouldn't spend a ton of time memorizing and learning a whole bunch of this type of selective precipitation stuff, because it just isn't going to show up too often.